All right, recording, good. Let me share my screen. Everyone can see my screen okay, good. Awesome. Cool. Let me also hide the floating heads so they're not smack dab in the middle of the video recording. Hide video panel. Awesome, cool. If you guys have any questions, since I can't see your floating heads, either unmute yourself or pop into the chat. Awesome. Yeah, so part 3 of the Pretty in es6 study group series. Wanted to focus on destructuring and how destructuring works in es6 or ES 2016, whatever you want to call it. Are any of you familiar with how destructuring works? You can either raise your hand or unmute yourself. Pop into the chat. Cool. Awesome. So yeah, this will be somewhat of a new topic for most of you then if you're not familiar. So I have a terminal here, got just an empty directory. If you guys want to follow along and kind of code out these examples that I'm showing you guys, feel free. I'm just going to create a file here. Awesome. So destructuring. The way destructuring works, and you can either destructure an array or an object. You know, it all depends on the data that you're getting back. So imagine, for example, if you have a function, I'll call it my array. And again, a lot of these examples are going to be contrived just to make things simple. Now you have this array, or this function that returns an array of 1, 2, 3. And in some other part of the program, or maybe even in another file, you want to consume those values that are returned by that array. So you'd create a variable, ARR equals to a call to foo, and you get back that particular array. Well, what if you wanted to reference these individual values of 1, 2, and 3 from that return value? You know, you'd have to do something like var a equals, ARR 0, and then do the same thing for the other two values. You know, it can get a little cumbersome. What if this array, had 100 items or 100 elements? So, and you wanted to reference each one individually, then you'd have to be like, okay, well, the number, 82nd element, I'd have to do, C of, 81, so it can get kind of messy. So they created a concept called destructuring. And essentially what we're doing here is we're destructuring. The act of what we're doing here is called destructuring. It means we're taking a structure, this array here, and we're deconstructing it into smaller parts. Lines 7, 8, and 9. And we're doing that through assignment. Assigning variables will distribute to those smaller parts of the array. So with es6, we're given a more concise option, that's a little more declarative. So how does that work? So let's take a look. Let's say we still have this function, myArray, that returns this particular array. What we can do then is on the left-hand side of the equal statement, create this bracket-like syntax that looks like an array, but it's not. And then declare the variables that we want for those individual values. So it's var, and then the array syntax, or the brackets, A, B, and C, is going to be equal to a call to foo. And what es6 is doing is it's declaring these variables and setting them equal to these individual values that get returned from I called foo, it's actually my array, sorry. Cool. So that's what we're doing. So all of this is accomplishing what we did prior, where we had the 4 lines of code. So if we were to console.log a, and we run node index.js, we can see we see 1 that's logged to the console, and so on and so forth. So again, what we're doing here is we're declaring these individual values, and because we're wrapping it around these brackets, what we're extrapolating these respective values from the array that gets returned from my array. Does that make sense? Any questions? Cool.
Just a quick question. So it's kind of the same concept as iterating through an item and then collecting that item in that particular array or the index.
Yeah, that's you can put it that way. It's not necessarily iterating through this array, and there is code behind the scenes. But what we're saying is, okay, declare a variable called a and set it equal to the first element that gets returned from a call to my array. And then so on and so forth. Declare a variable called b, declare a variable called c, and now we have 3 individual variables, a, b, and c, that are set equal to these values that get passed back. Well, let's say that we only returned 2 items from the array, and we still attempted to destructure a 3rd item from the array that gets returned. So let's do this. A, B, C. What do you think is going to get logged to the console? Anyone wants to venture to guess? What's going to get logged for A, B, and C? You can pop it in the chat or unmute yourself, however you guys want to guess. I'll try to run it here. Oops. Yep. 1, 2, and undefined. Sorry, I didn't notice the chat. Okay. Cool. Yep. 1, 2, and undefined. So we can attempt to destructure, but it'll just declare that. It's the same as saying, var, let's do it the old way. Var array is equal to a call to my array. Var a is equal to R1 0, b, and then if we were to do var c, there is no 3rd element in the array that gets returned, so then c is just going to be equal to undefined. So all this here accomplishes what we have to do in 4 lines. What if there's more than 3 elements? Okay, yeah, great question. That was going to be my next example. So let's do 3, 4. And we only destructure 3 elements, or the 3 items from my array, then 4 just gets thrown away. Yeah, there is no, essentially this value gets thrown away because we didn't destructure it from the return value. Yeah, good question. Awesome. Any questions so far? Cool. So we can also set default values when destructuring. So let's go back to the example of 1, 2, and 3. Let's say that 2 was undefined, or the second element was undefined. What we can do in our destructuring of the return array, we can use default arguments. And now we have a value for b because we set it as the default value. But if we actually pass in a value, I'm just going to call it 5, then now we see 5 is logged to the console. So there is the concept of using default arguments, very similar to the default arguments that we went over last week. Just wanted to illustrate that particular concept. Awesome. Let's try this. Let's assume null is returned from my array. And we still attempted to destructure values from a null object. What do you think we're going to get when we attempt a console log? Yep, somebody said null. All right. When in doubt, undefined. Could be, yeah. All right, let's give it a try. So we get an error, a symbol error. So this is an exception that gets thrown of type error. So there are ways to combat this if you wanted to. We can have a condition of an empty array. So what we're saying here is, okay, let's destructure the values that come back from my array. And if my array is either null or undefined, then we're going to try to destructure from an empty array. And that'll prevent a null exception or an exception being thrown from the program. So if we were to run this code and attempt to log A, B, and C, let's venture a guess in terms of what it's going to be logged to the console. Let everyone ponder that. And I'm going to hit enter. Cool. So when we attempt to destructure from an empty array, and again, we avoided this because we were using this conditional, this value was null, so it reverted to the opposite side of that conditional. So now A, when we attempt to destructure A from an empty array, A is undefined. B would normally be undefined, but because we set a default argument for that value, we see 10 logged to the console. So there is a value for B, and then C is undefined. Cool. Awesome. Any questions? Pretty self-explanatory so far. Cool. So now let's combine what we learned last week in terms of the rest operator with destructuring. So let's say that I had here an array 1, 2, 3, 4, 5, 6. And down here, I destructure A, B, set it equal to a default value of 10. And actually, let's do this to get a little more crazy. C, which will be set equal to 3. And then we used ... args. For those that were able to attend last week and remember how the spread operator or the rest operator works, what would the value of args be? I think it's safe to say that A is going to be equal to 1, B is going to be equal to 10, because again, it's undefined from the second element in the array. C is going to be equal to 3, but yeah, args, let's go ahead and see what the value of args is. So it's an array of 4, 5, and 6, because it gathers the remainder of those values into an array. So yeah, so they're not the individual values of 4, 5, and 6, they're an array of the remaining values because it's gathering the rest of the arguments. That's why they call it the rest operator, because it's collecting the rest of the arguments. So then if we do D here, D is going to be equal to 4, and then args is going to be equal to an array of 5 and 6. And I didn't log D, so that's why we don't see D in the console. Cool. So this is using the rest operator in conjunction with destructuring. We're combining the concepts that we've learned the last couple days or the last couple weeks. Cool. So now let's talk about nested arrays. So let's say you have an array of 1, 2, 3, and then the fourth element in this array is an array of 4, 5, and 6. So let me know, how would we destructure the nested array into individual values of, let's say, D, E, and F? Let me just get rid of this here to avoid confusion. So we'll put B back to its original value of 3. So yeah, how would we pull out 4, 5, and 6 from this nested array? Somebody wants to attempt sample code either in the chat. Yeah.
I would just think that we nest our line 6, like ABC, and then nesting another array inside that.
So like,
yeah, like F, yeah, and then D, E, F.
all right, let's give that a shot. So let's only log D, E, and F. Get rid of args. All right, so ideally, D, E, and F will be 4, 5, and 6. So let's try that. Exactly right, Steve.
Well,
yeah.
Good guess.
So that's the thing with destructuring is if we know the shape of the object that's getting returned, we can match it identically and pull out those individual values. So that's one great thing about destructuring is if we know the shape of the return, then it'll be easy to destructure those individual elements from that return value. Yeah. Cool. All right. So that's array destructuring. Okay. Any questions on array destructuring before we move into object destructuring? Oh, question here. All right, let's give that a shot, Brian. Okay. So we're going to attempt to destructure D1, D2. All right. Let's see what happens. And we broke. Yeah, because what we're doing is we're actually just declaring variable names. And, you know, we would rarely ever declare a variable D0 equals, you know? So that's what destructuring is. We're just declaring the variables and then placing those variables in areas that we want to assign those values based off of the return value of the structure that's coming back to us. Yeah, well, I'm great you pointed that out, so then I can illustrate, like, we're not actually, you know, pulling out those values in this destructuring here. We're declaring those variables and then identifying spaces in the return value where those variables need to grab those assigned values. Yeah, good question. Cool. Awesome. Okay, let's move on to object destructuring. Unless somebody has a question. No? So let's say we had a function called myObject that returned an object. I've got that here. So when it comes to object destructuring, very, very similar to array destructuring, where we identify the shape of the return structure and declare variables. So we can see here, 1, 2, 3. Oops, just run it again. There we go. And again, all it's doing is, but here's the thing with objects. Let's say that I named my variables F, G, and H. It's going to break. Oh, whoops. There we go. So we get back undefined. And with objects, we need to make sure that the variables that we name in the destructuring pattern is equal to the keys of those objects. So A, B, C. And then likewise, A, B, C. If we were to rename this particular thing to bar, then the first object we need to destructure is bar. And actually, that's not true. It doesn't need to be the first, because now they're all named. So we can actually do C bar, oops, B, B, C bar. There we go. So even though we destructured bar as the second object or the second variable, because it matched up with the key from the return object, it still mapped it when we logged bar to the console to the appropriate value, 1. So with objects, we need to match up the names of the keys when we destructure those particular values. Cool? Awesome.
I have a quick question, Cernan.
Yeah.
When would you destructure a structure, whether it is an array or an object, like a use case?
Yeah, I'm going to go over an example towards the end of this, a real world quote unquote example, and I'll show you, where this would normally be used. Good question. Yeah. Cool. Awesome. All right. Just double check here. So now let's say we have a nested object. So let's go back to A, B, C. And then let's say we have D, but that's equal to an object. We pull out the value of 4. So we have an object that has a nested object as one of its values for the key of D. So the way that we would break that out. What was that? Question? Oh. All right, so A, B, and C are self-explanatory. It's going to be set equal to 1, 2, and 3. But how would I pull out 4 from that nested object? All right, we got a guess of D dot E. Okay. Let's try it. Let's just log D to the console. All right, unexpected token. Remember, what we're doing is we're declaring variables. So rarely will we ever declare D.E initially. we declare an object called D, and then do D dot E. Yeah, good guess though. So if remember about identifying the shape of the return value, we know that what we're going to get in return is an object that has a nested object as its fourth value. So what we can do then is destructure that particular value as E. So let's log E to the console. And we get back 4. We could just destructure D as the fourth value. And if we log D, it's that entire object. But if we wanted to extrapolate just the 4, then we would need to match the shape of the object and destructure that value from the key. And that'll be equal to just 4 rather than the object itself. There we go. Cool. Awesome. So that's just destructuring in terms of return values. We can also destructure function parameters. So let's take a look at this. Function myfunc. And let's not define the parameters yet in the signature. But let's say I called myfunc. And yeah, that's a good way. Extrapolate, extracting and interpolating at the same time. That's a good way to coin that term. 43, 54. And this is going to be a string of hello. So I'm calling myfunc, and I'm passing in 2 arguments, the first one being an array, and then the second one being a string of hello. So I can destructure these individual values, in my function signature. So I'd use the same concept, A, B, C, wrapped in array-like syntax, and then this is just going to be string. So then I can console.log A. I'm just going to console.log A in string. But we're destructuring and we're pulling out the values of each individual element that gets called or that passed into this function call. This is destructuring inside the function signature. There we go, 32, which is the value of the first value that I pass into the array, and I'm pulling it out here. And then I'm just going to quickly apply the same concept using an object, A, B, C, and then wrap this. And log that, and then we still get the same result. Cool. Questions?
Yeah, I have one.
Yes.
Are those values on line 6 always hoisted to the top then? Or do they even need to be?
These values on line, no, yeah, they're not hoisted. Yeah, good question.
Okay. How does, I guess I'm curious how line 1 knows about it then. Or maybe I'm misunderstanding it.
Yeah, line 1 doesn't know until we ultimately call that function.
Oh, okay, I got it. Okay.
Yeah.
And we're calling it on 6 and it knows at that time.
Right.
Okay.
Because line 1, when we define this function, what we're telling the function is you're most likely going to get passed an object, and if you do, assign A to the first value of that object, B to the second value, and then C to that third value. I mean, we could very well call myfunc with nothing passed into the object, and when we log A, we get undefined. But what we're telling this function is, hopefully you're going to get passed some kind of object, and if so, set these values. And then again, let's say that for whatever reason, let's say it was a function called my name, first, middle, last. And let's just, don't worry about string that gets passed in. And then we were to call my func with first, turn in, last, Bernardo. Yeah, and I'm not going to call it in order. So first, middle, last. Oh. There we go. My name. There we go. So again, we're telling this function, my name, that it's hopefully going to get past an object, and that object is going to have keys of first, middle, and last. And if so, then set those values for those keys equal to these variables that we're declaring here inside this function signature. Cool. All right, so now let's take a look at an example. I'm going to touch index2.js. We got 2 files now. So I'm going to create, and I guess we can call this calculator. And I'm going to declare a couple of methods. And I'm going to declare subtract, multiply, divide, minus b, times b, and then a divided by b. Awesome. And then what I'm going to do here, I'm going to export these functions. Module dot, this is a node thing. Yeah, no worries, Steve. I'm going to post this video up to Flatcast so you can watch the last few minutes. This is the last example that I'm showing anyway, so cool. All right, so I'm going to export these functions or these methods in an object. Cool. So again, what we're doing here is we're defining these particular methods, and then I'm going to export these methods in the form of an object. So this file is sending these particular methods out in object form. So now in my index2.js, what I'm going to need to do is require that file. So var calc equals require, again, this is node stuff, calc. I mean, technically, you could add the .js, but you don't have to. Cool. So now, let's console.log calc here. And we're going to do node index2.js. Cool. So we get back that object. That's the return value when we console.log calc. Because we required that file, this value of calc is now equal to that object that gets returned by exporting. We can see here that now we can start to utilize these particular methods. So if I wanted to add 2 numbers, I can do calc.add, because again, it's an object, pass in 5 and 6. And if I were to console.log, so this is var 11 equals the return value of calc.add 11. Let's get rid of console logging this. We can see we get 11. So this is how we would have had to do it prior to es6, is declare a variable, set it equal to the requiring of that file. Now we have that particular object. But knowing now that this is an object that we get back, we can apply destructuring to that return object. Because again, all we're getting back is an object. So let's say that we wanted to utilize just only the multiply function. Because otherwise, let's say that my calc file had 1,000 different methods instead of just add, subtract, multiply, divide. Well, if I required that entire file, then calc is going to be an object with 1,000 different keys and values. But let's say I only wanted one. This index2.js file only wanted the multiply functionality. Well, I can extract that by destructuring multiply from that return value. So var 30 now is equal to just multiply and pass in 5 and 6. Now we can log 30 to the console, and we get back 30. We could, I don't have a transpiler. Let me show you import. I'll show you how it'll from in or calc. Yeah, you can see we would need to transpile this code using Babel in order to use import. Right now, imports aren't supported right out the box from Node. That's why we have to use require. But yeah, normally I would use import, and then here I would use export and export that object. Yeah, good question. Cool. All right. So now you can see the power of destructuring is, if you have a particular module that has, tons of methods, you can only pull out certain of those methods. Let's say you had an index.3.js file or index4.js, and each individual index file only needed 4 or 5 of those methods. Then in each of those respective files, well, you can pull out the ones that you need, and then utilize those particular methods. So, cool. Awesome. So that's destructuring. As you start to move into Angular, maybe even React, if some of you guys are going to be in that particular track, you'll start to use destructuring a lot more once you start pulling out modules from certain programs. So better to get used to it now. Any questions? Good? Cool. All right, you guys have been great. Last call, otherwise I'm going to let you all go. NG2. So Angular 2 has been released, and they are actually going to be using semantic versioning now with Angular. So Angular 3 is on the horizon. Oh, for Learn, not sure. Not sure if they're developing an Angular 2 curriculum or track for Learn. React is done. They just need to ship it, and they hope to ship that in the next week and a half. So if you already graduated, you have access to the React track. But for those that are still in the program, they're going to launch React. And not sure what the determination is in terms of who gets React and who stays on Angular. I think it's where you are in the program. If you're already far into JavaScript, then you're going to get, you're going to maintain the Angular. But if you're still in the end of Rails, you may get loaded into the React track, or you may get a choice. The logistics for that, that's all on the ops team, so I'm not sure. But I'd learn both. I mean, half of the jobs out there are still Angular based, so it doesn't hurt learning both. Cool. All right, guys, have a good night, and I will see you all next week for part 4. Take care, guys.